Assalamualaikum and good day to all my panels. My name is Muhamad Farid bin Marudin under supervision Madam ADIBAH HANEEM. I would like to present my project, which is preparation and characterization of calcium phosphate from cockle shell to ball milling method for biomaterial application. This is my presentation outline for today. I will start with the introduction and end up with conclusion and suggestion. Hydroxyapatite, in short form HA, is a calcium phosphate similar to the human heart tissues in morphology and composition. In previous study, Penny and others state that cockle shell has calcium carbonate that can change into HA. An important advantage of hydroxyapatite is its stability when compared to other calcium phosphates. Thermodynamically, HA is a more stable calcium phosphate compound under physiological conditions as temperatures, pH, and composition of the body fluid. Due to its bioactivity, it encourages the bone to grow and restore the defects. Next, another advantage of HA is S2 conductivity and non-toxicity. For the biomaterial application, it used in human body material, implant material, fertilizer activities, replacement in constrict material, manufacturing of surgical devices, and lastly, catalyst for biodiesel products. Next, we move to the problem statement. First, incorporate byproducts and waste from cockle shell as alternative in obtaining HA. Next, cockle shell has no economic value available in large quantities and dumped in landfill. Third, the commercialization of cockle shell for produce HA not widely performed. Lastly, the high consumption of HA is predicted to increase the target market over the forecast period that's stated by Chirumalai. As we move to the objective, first is to produce hydroxyapatite powders from cockle shells waste by ball milling method. Second, to characterize on the synthetic HA by Srd, SEM, and Fdir. Lastly, to study the effect of different reaction temperature to produce HA from cockle shell. So we proceed to the methodology part. We start with the collecting shells, clean and wash, boil to eliminate contaminant from the cockle shell. We dry in the oven, we crush the small size using pestle mortar, and the powder was sieved to get 70 micron using sieve shaker. We calcine at 800 for 1 hour to get calcium carbonate, and then we mix the powder with diammonium hydrogen phosphate with the cockle shell powder, and then we ball mill at 5 hours with RPM, with speed 400 RPM, and we heat treatment with 900 degrees Celsius, 1000 degrees Celsius, 1100 degrees Celsius, and then lastly we characterize using SEM, Fdir, and Srd. That's all. Proceed to the result and discussion. Figure above show SEM image of the product prepared from cockle shell powders and diammonium hydrogen phosphate powder for mill for 5 hours. So we have here HA pure with SEM image, and this is a data distance link between particle, and we get average distance link between particle is 19.54 micrometer. Next, for the HA 19 degrees Celsius, the distance link between particle we get 6.158 micrometer. And for the HA for 100,000 degrees Celsius, for the distance link between particle we get a 4.063 micrometer. Next, for the HA 1100 degrees Celsius, we get the value 2.688 micrometer. The microstructure of calcined HA is highly agglomerated nanoparticle of the direction of 900 degrees Celsius for 2 hours. A few small HA rods grew over the surface of the powder, with an increase in heat treatment temperature to 1100 degrees Celsius. HA rods grew across nearly the entire surfaces of the powders. The void and porosity from the particle are decreased due to the heat treatment temperature increase. The morphologists were in agreement with the study done by Wu and others. Next, we move to Srd analysis. Figure above illustrates the Srd pattern of HA produced at different temperature. The HA produced at 900 degrees Celsius heat temperature show broader peaks compared to 1000 and 1100 temperature, where the peak indicates that the sample has less crystallinity. Besides, there is calcium phosphide. Peaks appeared on Srd pattern of HA with 900 degrees Celsius. This is probably due to impurity during pre-treatment of HA powder. Meanwhile, HA produced at 1100 reaction time has sharper and more apparent peaks. This indicates the HA with 1100 temperature has higher crystallinity compared to HA with 900 1000 degrees Celsius. So to calculate the average crystallite size, we have used the Srd expression using data from the Srd to determine the average crystallite size. So increase the reaction temperature has increased the crystallinity of HA. This finding was supported by Liebman and others. Next, we move to the Fdir analysis. Figure shows the Fdir spectra of HA produced at various temperature. HA produced at various temperature in this analysis. From the analysis, there are biological bond present, which is carbonate, phosphate, and hydroxy starch. Carbonate band presented correspond with phosphate band. There are 4 vibrational modes present in phosphate ion. The phosphate ion in this group in this experiment is V1, V2, V3, and V4. After heat treatment process, hydroxy starch is absent due to the heat treatment process. Basically, all samples show that it has carbonate constituencies. Common bands of carbonate HA was detected. This indicates that HA produced at 900 degrees Celsius reaction contain higher carbonate ion concentration. According to McAdary and others, increase in carbonate ion concentration has reduced the crystallinity of the produced HA. The Fdir results are supported by Srd result before, where HA produced at 900 degrees Celsius has lower crystallinity compared to the 1000 degrees Celsius and 1100 degrees Celsius. For your information, all my data for Fdir and Srd are supported by previous study that carried out by Wu and others. Next, we move to the conclusion part. After all is said and done, the result of this study have demonstrated that HA powders have been created for sample as demonstrated by Srd, Fdir, and SEM analysis of COCKLE shell waste. The resulting powder's particle size appears to the same as that of the bone meal powder's original particle size, and agglomeration has become more significant as a result of high temperature sintering. Next, Srd and Fdir studies have confirmed that 1100 degrees Celsius is preferable to other heat treatment temperature because it has a high temperature value and produces a larger concentration of crystallized HA. Next, increasing temperature shows the Srd diagram shift to crystalline phases as represented by number of peaks. Finally, it can be stated that heat treatment temperature is an important parameter in the synthesis of hydroxyapatite. Last but not least, for the suggestion part, the combined study will provide more details about nanostructure and field of environmental science, and the technique we require to use will depend on the requirements. Second, PHOSPHATE can be used to raise the quality of the image because it can obtain a focus image for the end of the result. Third, to obtain optimal heat treatment temperature, TGT analysis that can control temperature program can be used. Lastly, HA is a brittle material that breaks easily. By covering the hydroxyapatite with a biodegradable polymer, hydroxyapatite-based composite can be transformed into osteoconduction and osteointegration enhancing materials. So, this is the end of my presentation. Thank you. Assalamualaikum.